This conference will now
Right.
be recorded.
Hi guys. Myself, Ravinder. Just to give a little introduction about myself. I'm working on SQL DBA close to 20 years now. I'm working on MongoDB more than 10 years, and MySQL and Postgres more than 8 years now. I'm working on, and I do work on MariaDB also, and I do work on AWS and Azure cloud technologies as well. My role is actually I'm working as a tech lead escalation engineer. So any escalation that we get, I'm the point of contact to handle all of that in the environment. So that's a little introduction about myself. So basically, we're going to talk about these points today as an agenda: MySQL history, who created the MySQL, and what is the journey behind the scenes, what is the latest versions, and all that. Then, what are the outstanding features of MySQL, which are not available in other products? Comparatively, in fact, they are little outstanding here and there. They will be same, but comparatively they are efficient and better in MySQL. Those features we're going to talk about, and how MySQL is better compared to other, or how you can compare with other products. A little bit of introduction there as well. It is open source, and how do you get a support if you want, and who can help you if you run into issues, and how we can approach the like Oracle also in terms of support. So if you go to the enterprise, there will be support. If you go to the community model, you need to buy a yearly support model. I'll explain that side as well, how we can get the support as it open source. Why MySQL, Oracle is giving us free, like it's open source community. In fact, it's so sophisticated, it can handle anything except the feature side, inbuilt data encryptions, monitoring, upgrades, and there are few things which you can't do with the community. Okay, so but all data administrations you can do absolutely what you can do with the enterprise. So there also will the little focus there also will give it in the today's class. Cloud providers are actually the people who are gaining a lot of money from the open sources. Like we know that AWS has Aurora, MySQL, Postgres, everything, right? So they developed their own version, and then they're selling it off on the platform as a service and getting a lot of money. So there are also a little bit of information. And database general limits, what MySQL really supports, what kind of limits it can support, we will talk about. Then why we need to learn MySQL when we have many products. All as a conclusion, I'm going to talk about. So just to talk about the history, basically, Michael Wideness, this is a guy who, laid out the stone where they started the product development. Along with him, David, Axmark, they developed this product in the 1994. In fact, they belong to Sweden, Swedish company. These people, and they have the company called MySQL AB. The company who developed this MySQL is MySQL AB. In fact, that is a company name. So initially, they have released in 1994 MySQL version 1.0. It was for the internal use only. They did not release to the entire product to the public, as it was not so efficient and a lot of features was missing, and it is not so efficient during that time especially. So but down the line they made the product absolutely with all the features. There are many features were not available at this time. You can't modify the data. You can you it is a read only kind of thing. You can't create triggers, functions, stored procs. You can't create such objects in the lower version. In fact, from 4.0 roughly, there they have added more functionalities to the product. That's where the MySQL started getting implemented in the market. But anyway, so since it started, it is open source only. Anybody can use it as a free software in any of the companies. But they have given two kinds of licenses. Even MySQL AB product also given MySQL Community Edition at free of cost. But you can use at free of cost. But if you're using this software in any other third party software, and that third party software source code is not given to the market, they have to pay the money. So it's an indirect licensing model. APGL we call it as. Okay, GPL, public general public licensing model, where anybody can use it. But if you are taking the MySQL into another product, and then that another product is not exposing to the market as open source, then they have to pay the money. Okay, so that's the licensing model they had. And at the same time, why any open source, actually they'll give it as open source, nothing comes for free. In fact, they get the money from the support. In fact, so MySQL AB was earning the money through the commercial license, at the same time from the support as well. That's how the open source drive in any product. In fact, so the APGL is kind of a, where they indirectly getting the money, and support is a direct money. In fact, they come to the product and ask for the support. That way they can get the money. So this product was actually acquired by Sun Microsystem in the 2008 for 1 billion. Okay, so they acquired the entire product. They took the control of the entire MySQL. So it took the control from the MySQL AB completely. So they started developing the product. So, but they did not release any new versions anyway. They developed some good features. But meantime, 2008 to 2010, they developed real good features in between. But in the 2010, they acquired the entire Sun Microsystems. In fact, who the Oracle completely acquired for $7 billion, $7.4 billion. They completely acquired. So Sun Microsystems is completely part of the Oracle now. So the MySQL is also part of the Sun Microsystem, so they got the complete ownership on the product in 2010. That time, what happened? It's open source, right? So many people implemented in the market. They are using it absolutely effectively. So there was a case against the Oracle. In fact, why? Because Oracle is a already licensed product. MySQL also, if becomes my licensed, and what about the people who are using the product already? So there was a case, filed against the Oracle, why they should not purchase this company, kind of. Then Oracle agreed. They will keep the product as open source only. Okay, they don't make it as a licensed community version as it is. The product how it is at the moment, they'll give it as free from 2010 to 2025 is a agreement. In fact, 2010 to 2025 is a open. MySQL should be kept as open source only. Okay, and with the advanced features what they are developing, they are giving it as enterprise anyway. How they bought it from the Sun Microsystems, that product is completely even Microsoft, the Oracle acquired the MySQL, still they kept it open source because of the rules, regulations. In fact, the company, the who developed the Monte, right? This Michael Ordinus, he was not trusting the Oracle. They definitely, make this licensed heavily, and people can't use this product. That's where this guy is forked one more product called MariaDB. He took the entire open source code and he started another, product journey called MariaDB. MariaDB is also slowly getting deviated. Till 2018, MariaDB and MySQL, there was no difference, though they are different product handled by the open source people, and MySQL is a licensed, it's enterprise and community, both we have it. It's owned by Oracle. So both have almost drop-in functionalities, like you can interchange the product data and all directly. But now things got changed quietly. Okay, MySQL released 8.0 and 8.4 now, at the moment what is active. So they're diversifying the product from the MariaDB. MariaDB not directly compatible anymore with the SQL nowadays, because it is getting compatible, not completely not compatible, kind of. It is slowly getting completely deviated. Down the line they are going to become a completely different data sets. They have different compatibility model as well. So it is started already. This MariaDB following 10.0 version, where the latest one, it is following 8.4. I'll talk about character sets, how data is actually, the features are differentiated between the MySQL and MariaDB. So one thing, Oracle actually keeping the MySQL still as open source, though the European Union actually kept a rule to the Oracle that Oracle should keep the MySQL as open source till 2025. 2025 we already crossed, but still Oracle is giving as open source only because they are able to gain the lot of market through the MySQL. In fact, you are giving it free, they're implementing free, they're coming for the support. Oracle is getting the money from the support. At the same time, when the company is growing, when the MySQL is given as free, the company is growing, they need the enterprise features, they are coming to the enterprise features and getting a lot more money than the support. And once they enrolling the MySQL, they're getting the access to the market. So they also slowly, when the company is becoming too big an enterprise, they are coming to the Oracle also. So they are getting the access to the market through the MySQL open source product. Mike's Oracle is giving the open source, right? How, why they are keeping it open source only still, though the law what they have agreed in 2010 was over, because it's giving the access to the market, in fact. Okay, that's where they're still keeping the MySQL will community edition as open source. It will remain as open source only forever. That's what their commitment, because they are getting a lot of benefits by doing that. Initially they thought like it is a loss for them giving the community edition to the market, but eventually they understand the scope of the market deployment, and then what is the value they are getting out of it, they understood. So it is will be definitely open source only, the MySQL community edition. So there are many performance improvements, in 5.0, 5.1, 5.5, 5.6, 5.7, multiple versions they have released after they acquired from the Sun Microsystems, because there is another product, MariaDB, created by Monte, who uh, initiated this initial product, right? So that can be competitive. If that becomes competitive, then Oracle communication will be killed out. Nobody will implement it. MariaDB is completely open source. You don't have to pay at all. So if that becomes competitive enough, then MySQL nobody implement. If they nobody implement, the product will become useless. That's why they rigorously developed lot of new features up to 5.7. We will talk more in the course anyway. I'm just giving a informational thing here. Right. So then MySQL started from 5.7 to 8.0. Oh, in between, they did not release the 6.0, 7.0 at all, because during the transition phase, where it acquired Sun Microsystems, acquired Sun Microsystems to Oracle acquired. In between, whatever the developments they made, they applied to 5.7 itself. They did not release 6.0, 7.0. Directly, we are into 8.0 version now, which is the latest 8.4 at the moment. Okay, so this is a little history, guys. It's not too much important for us to really know, but anyway, just giving an information how the journey was made up to the Oracle, because it's not the Oracle developed product. It is developed by the MySQL AB to Sun Microsystems to Oracle. The journey was happened like that, and it is still open source because the Oracle understood open source access to the market. In fact, when market is using the product, they will come for the support. Then slowly enterprise, then they can come to the Oracle as well. That's the expectations of the Oracle. In fact, so it is one of the, I can say that Postgres is also very popular, like MySQL. It's one of the most popular open source relational database. In open source, what good products we have, Postgres and MySQL is the first point of discussion we come. Anybody ask you, or what are the good open source RDBM systems? MySQL and Postgres is the top two that you need to mention. In fact, so MySQL is one of the top most, and it follows the dual licensing model. Even Oracle also following the dual licensing model. Even your community edition is free, but you are embedding this in any other product. Okay, any other product, you have to pay for embedding that product inside that product. If I'm taking MySQL, I'm building a product, in the that a product belong to me, I'm not giving to the market. I'm directly selling that that product a, as a licensed product. Then you have to pay for it, because community edition is free, but if you are taking this product and using in another software, that another software is not open source, you have to pay for it. So you're getting the money from that support and slowly enterprise. So that's what the expectations from the market. And if you look at 1994 to now, we are into 2026, so 32 years of experience into the product as open source, where it is getting developed. There are wide range of community support is available for the MySQL. Even you don't have enterprise, you can go to community and ask the questions. Okay, and people will respond. Only thing is, you can't demand. When you don't have a paid support, you are going to the community and getting the support. You get the support, but on the people's their own speed time, they may not respond you immediately, so you cannot expect the support immediately. So This is kind of boring, guys. I understand. Let's go to the actual content because this is not going to help you much in terms of interview sake. But anyway, if you're learning any product, knowing the history something somewhere help you. Now coming to the actual outstanding feature, this is where we're going to spend more time. So Postgres follows the multi-layered security model. Okay, when you are creating the user, you will mention the IP, you will mention the network, you will mention everywhere you can connect. The user authentication comes at the network layer. First, you have to come through the network layer, then you authenticate, then you enter, then you look for the permissions and all that, right? So every layer has a filter. If you are connecting from the network, are you allowed or not? Is firstly when you are creating the user, you will mention the IP, you will connect from that IP only. You'll give the subnet, you'll connect from the subnet, you'll give the network, you'll give the all. In fact, all probable control you have it from particular network, from particular host, particular subnet, so particular, not particular, everywhere they can connect. So we have the control. When we are creating itself, we can give that filter, in fact, for the user to connect. The first thing is network layer is this. Then you connect to the MySQL, then you have to have the permissions, how the permissions will be laid out, how inbuilt permissions will help you, how customized permissions will help you. We're going to talk about very in detail in the security model. We have password encryptions. We're going to talk about, okay, then role-based access controls, password validations. If password has to have a 12-digit and uppercase, lowercase combinations, it should expire after some days. Everything we can mention in the community edition as well. And you want to audit the information, okay, audit the queries what people are running. We can do all that. In fact, not advanced auditing, but in inside we do have certain monitorings that we can enable and find it who are doing what. Performance schema is a one good thing where all ongoing active sessions information will be available here. What kind of queries are running, what are good queries, what are the bad queries, what are the weight stats we have, and what is the latency, what is the IO you are generating. Everything can be found. We're going to see very in detail performance schema in the performance tuning. This is very much important. I'm going to spend good time on the performance tuning anyway in the MySQL. There we're going to use performance schema output to analyze the workload and take the what is the bad queries, what is the good queries, what are the queries are creating the workload, and which can be killed immediately to control the system. Everything will be covered when we talk about this particular output. It will maintain all the runtime actual data what you are working on the MySQL. It will help us to find what is actually creating the issue at that moment. Online DDL is a one good thing in MySQL. We have online DDL in all products anyway. Like when we create the index, create index online, rebuild index online, using the tempdb in SQL Server. If you come to SQL Server, in Postgres also we do have similar concept. In fact, online, offline. Online means concurrently. There is one word we use concurrently to create the indexes online. So we have multiple ways. You want to make the any changes offline, online, okay, and partial online. We have three methods here. We're going to talk about copy, instant, in place. There are three methods. uh, See, I'm not touching as a practical as of now because these things that comes in the performance tuning. All these are all performance schema. Online DDL is something part of performance tuning discussion we have. I kept in the module anyway. We're going to talk about how it is going to help. Anyway, this is not so new in the MySQL. It is the same or more or the less in all the product, but how it will be implemented, we'll talk about. And point in time recovery. Point in time recovery supported by every RDBMS. If you can't do the point in time recovery, the product is a failed product. Because any database system, recovery is very much important. Without the recovery, we can't really, you know, um, we can't really sell the product, right? Your data is so important. If you can't really recover the data what is lost, your product is absolutely useless. You can't do you can't sell the product. And stored procs, views, triggers, functions, these are all common across all the products, so it's not outstanding anyway. Let's talk about here hybrid database. This is outstanding, I can say. Outstanding features here. the MySQL supports the let's see guys both in reality how this really works. Let me explain. We have the JSON support. I mean, NoSQL data support in the MySQL. In fact, you can operate the RDBMS data, NoSQL data within MySQL. Postgres also doing anyway nowadays. But quickly, if you want to see that how RDBMS, how MySQL is a hybrid database, let's quickly check it how it works. I have the MongoDB also quickly. So let me show that how MongoDB is a NoSQL product, how it is really, accept the data in any format, in fact. Okay. Let's see. Right. This is a MongoDB server. So show DBs, just have an idea. I'm not finishing anything here. Just important to have what is NoSQL, how this MySQL is supporting the NoSQL data. So example, MySQL is dynamic. Everything is dynamic. You don't do, sorry, the MongoDB is dynamic. If I use a database, it will create the database automatically. I'm going to create a practice. You don't have a practice database here, right? Local config admin. I'm using the practice. That's it. It will create the database automatically. Okay. So db dot student dot insert. The student collection does not exist. It will take the data on the fly. Everything is on the fly. Okay. You don't have to worry about. Absolutely, um, everything is on the fly here. Okay, name. Just I want to show few details. Then I'll do the same in the MySQL too. So here, let's give only two fields for now. So if I'm loading the data, if I load the next record with the three fields, not two fields anymore. Everything is dynamic here. Okay, so let me show this. Load data and then I'll show it. Okay, third record. How it look like? What is the JSON data? What is NoSQL data? In fact, uh, if I go and read, okay, db.student.find, data look like this. In fact, first record has the two fields, second record has three fields, third record has four fields. Data is absolutely dynamic here. There is no structure, nothing you defined. It is taking the data, you're loading it. There is no control on the data structure. In fact, it can be anything. It just accepts the data as it coming to the system. MySQL also will do the same, which supports the NoSQL data. So how it supports the NoSQL data? Let's see what data. Let me make a little bigger. Select database. What database I'm connected right now? Practice show tables. What tables I have right now? Don't worry about this. What I'm really just I'm giving an idea. Today is everything is an idea. I'm not finishing anything at all. Everything I'm going to discuss today will cover in our respective modules anyway. I'm just giving a gist of the technology. So here I'm going to create a table. Create table. Let's create table student. Okay, as number integer as name varchar 100 and address can have a lot of details, right? So I'm going to define as a JSON data, which is a NoSQL data. In fact, so I'm creating the table like that. Okay, and now if I go and check the table describe and student, if I go and check, we have three columns. One is a JSON field, what I defined here. Here I can load the data. Okay, insert into student values, little small maybe, right? Right. So here I'm going to load some data. Here I'm giving it a Ravi here and here. And the third field, what we defined is a JSON. So we need to load as a JSON object, JSON object, JSON underscore object. So here I'm going to define the data. So here example street, assume a case street. I'm defining this street as Popolagura example. And here locality where you belong to. Just I'm giving some information here. Kukatpally. Okay. And then city, if we want to define a city, okay, here city Hyderabad. Then I'll go with pin code. This is a pin code for address. Address has many things, so I'm defining a JSON for that, so that it will be easy for us to keep the data in one record. So if it is if in RDBMS term you create a student table, you create address table and keep the relation. That's how you give it. So now I'm loading this data. Now I'm going to load one more record. Let's do this. Second record. Just for use case. Street, I'll give it as Vajinagar. It's MySQL where I'm loading the data. Okay. How I installed all that, I'm going to explain. Let it be all this. So what I'm going to add is extra email. I wanted to add email for this guy. Email is what we calling it here is Pratap. Pratap. I'll show the data. Don't worry. This is a practical just justification. So now if I go and read the data, how it look like? It is RDBMS, but data look like this. You have the first field, second field is in the RDBMS format, but the third field is not RDBMS. This is a NoSQL format, in fact. Okay, it is out of RDBMS format. The MySQL supports natively both the things, RDBMS data format, NoSQL data format. The Postgres also does anyway. But this is one good thing where you can operate both the data types in MySQL. So now, if I want to read the data in RDBMS format, the data is in the NoSQL format, but I wanted to convert into RDBMS format and read the data, you can do that. Select S number, S name, and S address. S address. You give the like hyphen, double greater than. Okay. Then give this in the double quotes and the dollar. This is a format to call the JSON data. Use a field name. Okay. Use a dollar to which field you want to call basically. So I wanted to call city. City as city. I wanted to read that as city field. And another field I want to read it. S address, give the hyphen double greater than. Okay. And then dollar dot. What I wanted to know is street as street. Don't worry, this I'll explain in one class um, about this, how we manage it, because it's important to know. In MySQL, we will have a JSON data too, complex data, in fact. So when this kind of data is there, we have to do the deployments also. You have to modify the data as well. So when they're reading it, how they're reading it, how natively MySQL supporting SQL data, NoSQL data, both the data. This is how it supports. If you can see that, I can read the data in the RDBMS format. This is in the JSON format. I have loaded, and I'm reading the data in the JSON format. Okay, this is called JSON support model, where it supports the hybrid data model. It's a combination of SQL data, NoSQL data, relational, non-relational data together in one platform, which is supported by MySQL. It's one of the famous, in fact. MySQL supports the JSON data is one of the one good feature that we have in the market, in fact. And portable, like it's a portable. I know it is a ANSI compliant. What is ANSI compliant mean? In fact, the MySQL data can be migrated to Postgres, Oracle, Microsoft SQL, any product. You can convert the data from MySQL to other product, other product to MySQL. So if you are able to migrate the data from one product to other product, then you are ANSI compliant. If your product is not ANSI compliant, you cannot certify that product as RDBMS. In fact, all RDBMS family data products should exchange the data between them. That is a rule. If you look at Oracle to SQL, SQL to Oracle, and then MySQL to Postgres server to MySQL, in all these platforms can exchange data because they are ANSI compliant products. In fact, if they are not ANSI compliant product, means you can't transfer the data one product to another product. It's impossible. So all RDBMS relational database model systems are ANSI compliant. ANSI compliant means they can exchange data between the product, any product to any product, but they should you should have a middleware drivers. That's a different story. Every product has its own driver to convert the data to into native format, but the product should support that conversion of data, one product data into target product data. So that's where it becomes ANSI compliant, in fact. Okay. At the same time, it supports this MySQL supports on Windows, Linux, Mac OS, all platforms that you have in the market. Okay, it's not tightly coupled with anything. It's open source. You can run on any platform, any operating system that you have. Okay, that's one good thing what MySQL outstands anyway. Okay, reliable, of course, it follows the ACID compliant where you can't break the ACID compliance, but there are few things I'm going to talk about next slide, where statement rollback. This is one thing you need to understand. Let me explain that there only. Okay. I'll come back to there. ACID compliant, but it can deviate ACID compliant. It won't deviate. It will follow the ACID compliant, but inside the transaction, if for example I have a five statements, out of five, one got failed. If generally what is ACID says, either all should commit or all should roll back. MySQL follow in a different, little bit different in the atomicity. So, but it will follow the ACID compliant, but in the background, how the background is maintained, your transaction is something little different in MySQL than any other product. Other products are quite different in terms of atomicity. MySQL is different. How it is different? Still, it is ACID compliant. We will explain in the architecture. I'll explain very in detail architecture with better examples. Let me tell you this thing. Why should I ACID compliant? ACID compliant, where a statement level rollback. So that's what we need to understand. Let's talk about it. What exactly I mean? So example, I have the student table. Let me create one table. What exactly I mean, I'll explain you so that you understand. Create table, teacher. This is an outstanding feature in the MySQL. In fact, no other product does this comparatively. It is a statement level commit, not a transaction level commit. Then how it can be statement level? Why not a transaction level? I'll explain in the architecture. So here, what I just created is this. So let's add a unique key here to this one, right? So what I'm going to do, to fail the transaction, I need to add, so alter table, teacher, okay, unique country number. Let's say this is how it is, I guess. Right, it is accepted. So example, if I'm loading the data into insert into teacher, try to follow. This is a one statement. I'll explain very in detail in the architecture, not now, but still you need to connect to this. Insert into one example first record. Maybe I'm going to take some name here. Any name. Example funny. Okay. Address. Uh, okay. What is the structure? T number, T name, address. Insert into values. Okay. Right. It's loaded. If I load again, what happens? It will fail because added a feature, alter table, add unique on the T number. So the T number should be unique. I already, having here one. Okay. And then I'm trying to load again one. It is failing. It is duplicate key. It is failing. So then let's go in the loop. Begin a transaction. Okay. I'm beginning a transaction. Then I'm going to insert the data. What data? Here 2. And then I'm going to here 3. Okay. It's in the loop. Okay, right now we are in the loop because I started, I did not commit or ended yet. Then I'm going to give it one here. Okay. Then what does it? This will do. It will fail. Now I'll commit. It started here. It is ending up here. If I commit this, what happens now? So you should. This got failed. If it failed means within the transaction between the begin and commit, if one transaction, one statement fails, everything should fail. That's the rule. But MySQL is not like that. So let's go and read the table. Test teacher, right? Right. So you see that there is no, I mean, it accepts the second record and third record. It did not roll back. If you go to Postgres, let's go to, I do have a Postgres server also. Let's check this out in Postgres. It will fail in Postgres. So understand. Okay, let's not start. Let's say just a minute. How atomicity, how it works also I'll explain in the architecture, not now. Okay. So let's see what databases I want to go one of the database. What tables we have. Okay, I'm going to create the what table I was playing around here. Here, right? What table? Teacher table. Do we have teacher table? I had to have drop table. I'm dropping here. Right. So I'm going to create the same table here also. Create the same table. But when I'm creating itself, I'm going to add the unique because we altered, right? Unique. It's created. Okay. Now, if we go and check describe the table, we have the unique key already. Now I'll load the same data. Whatever I was doing, let's do the same thing here too to compare how it works. So I'm going to load the data here. Come on, why I'm closing this? Huh? So try to understand the difference. Uh, it is inserted one. If I try to load again, it will fail. The same thing what we have seen there. Now what I'm going to do, I'll start the begin. Begin here. Okay. Then I'm going to load the same data what I loaded here after begin. After begin I did here, I'm going to load the second record here too. It will accept. And I'll load the second record. It will accept. Okay. Now I'm coming to here where this failed one. Doing this. Now I'll commit. So what it said, duplication of this. This is started. I'm committing here. If I commit, what happens? Now you go and read, select asterisk from teacher. You will see only one record. In a begin to commit in between, how many statements are there? All should commit. All should be successful. If one failed, everything roll backs in all the products. But MySQL is not like that. This is a one outstanding feature you have in MySQL. It's a statement level commitment. Okay, it will commit at statement level, not at the transaction level. How it will be under ACID compliant? Basically, it's not an ACID compliant property, right? This should not be, but it will be ACID compliant. That I'll explain in the architecture, not now. You don't understand that if I explain. I'll explain the architecture. There are undo log, there is a redo log together making this as ACID compliant. There are two logs which maintains this, not one. Okay. So in Postgres, we have only one log, like a vals. That is only way you can have a recovery. Here you have two log files, one for the commit transaction, one for the uncommitted transactions. Uncommitted transactions, how they help you to roll back. Committed transactions, how you roll forward. I'll explain in the architecture. Then you understand this concept, how it is ACID compliant. Though I'm running a transaction, within the transaction, some statements are failed. Still, whatever is successful, successful. Whatever failed are failed. Simple. Still, transaction off partially committed, it is ACID compliant only. How it is ACID compliant? Where it is Postgres is failed with the same transaction, MySQL accepted the data for the same transaction. How in the background they are different. We'll talk about that. Okay, that's what about asset compliant. And statement level, I have a statement level rollback. Okay, if it roll back, it will only roll back the failed statement, not all. Okay, rollback in the sense this one, it is anyway not committed, it failed itself. So you can't fail the entire transaction because of one statement. Basically, that is possible in the MySQL. That is one good outstanding feature. We'll talk about in the architecture very in detail. Scalable, we have a multi-version concurrency control using the undo log file. Undo log file is a one where before you do any transaction, first, uh, before data will be entered there, after data will be entered there. Okay, once the commit statement happens, then undo log get cleared. Redo log will maintain all committed transactions. Undo log will maintain all uncommitted transactions internally. So using that, multi-version concurrency control will be achieved. No writes reads will block in MySQL at all. You're writing and reading parallelly, they don't never block at all. Only only write can block if they are overlapping data. So very high concurrency compared to Microsoft SQL, Oracle. Basically, it gives a better concurrency because of there are two log files we'll talk about. Okay. Supports table partitioning. We have multiple types of table partitioning. I'm going to explain in practical, very in detail, table partitioning concept. Very important. Table space, one module I'm going to add. I did not add to course already. We have a table space management, database management, and table management as one module. I'm going to add it. There I'll explain very in detail how data can be segregated. If you have one table space, you're loading everything into one table space, which is not good, in fact. Okay, we can create multiple table spaces. We can create a table level files. Okay, there are multiple things we have. We have a default table spaces, or you want to create your own table. Every table you create separate file you want to create. What exactly I mean, let me tell you with the diagram a bit on it. Example, I have a database. I have the one volume. If I create a database, by default it will go to one volume as a table space. Okay, here I'm creating lot many tables, and it is becoming uh, too big. Then I can create one more table space. Well, create some objects like tables. This concept I'll explain in practical in that module, then only you understand. Your database, a database got created here. Okay, so lot of tables you created, it has started growing. So I can't accommodate anymore. Then I'll create another table space. I'll map the new tables here. Database will remain there only, but objects when I create, I can give this one. I can give this one. I can create one more table space. I can migrate the tables as well if I wanted. So everything is possible. This table space management is important to understand how tables and data storage can be managed in the with background. That's something I'm going to explain. Very important. Okay. Invisible indexes. This is so important feature. MySQL outstands here. In fact. So let me show you this very in detail. Show tables. So do I have any data in the customer? Let me see. Select. I loaded some data, I guess, there. We have 1,000 records. Good enough. So if I read example, select strict from customer. Let me show the data, some data with the limit 100. 100 is too much. 20 record. 20 record. Let's read. So this is how the data look like. This is how the data look like. So I'm going to create a index on the address field. Okay, on the address field. Let's create it. Without the index, let's do this. Explain the same query if I do it. What happens? This will do scanning entire table, no keys, no supporting keys at all for the query. If there is no supporting keys, then it will scan the entire table. It is going to read all the data, which we don't want, in fact. Okay, so it read 1,000 rows. You can see that all 1,000 rows. It is it actually it filtered 20 records, right? 20 records, limited 20, filtered 100%. Anyway, so it read 1,000 records. So let's go. I'm going to create index. Create let's do this alter table. Table name is customer. Let's see the structure. Describe. Uh, See, these are all just understanding, guys. For now, we will see very in detail in the respective modules. So I have three fields. I want to create index on this field. So because I wanted to give a filter on the address. So let's do this thing where address Hyderabad equal to. I don't have index for now. Okay. Now I'm reading it. Okay. We got here all 1,000 rows are red here in the background. All 1,000 rows are red. So I want to create an index. Create index or alter table. Alter table is customer. Add index. IDX index name. What do we call here address, right? So let's give it an address. And what field I want to give it address field. So I'm creating an index. Okay. What is that field name? C address. Okay. Right. So now show indexes from customer to see the indexes. So I have one index. Okay. ID address covering the address field. Columns covered under this index is this. So now if I'm going to read, it's the same data, right? Right now. So now you can see it read 194 records only. In the previous case, it read 1,000 records. Now it is 194 only. So for this condition, we have only 194 records, and it is use the index key. You can see that use the index key. You can see that. So basically, if you have too many indexes in other RDBMS, what do? We disable the index. Disabling the index in the sense it will not get updated when you update the data. So it is equivalent to you don't have index. Okay. In MySQL, you can make the index invisible so that it will not be used for the queries, but in the background it will get updated. Whatever the data you are updating, whatever the rows you are modifying, it will track your modifications in the index pages. You are making it invisible without dropping it. So what is advantage with this one? Basically, in other products, generally you drop the index or you disable the index. If you disabling means you have to rebuild the index to enable, which is a expensive operation to the system. In MySQL, you can disable it. When it is disabled also, it is valid for the system. It will update the index. Okay, before you drop the indexes, you disable the index and run the queries. If they are improving it, and drop it. If it is not improved, if it is impacted, you enable it immediately. Index will be online. It is serving the data absolutely good. Don't have to do the rebuild anything at all. So that's a one good feature we have in the index, invisible indexes. So alter table customer. Let me show this as an example, but I'll show this in the performance tuning very in detail. It's very much important concept. Okay. Alter index. Okay. Index name is what we just created. This one. Invisible. Okay. Now we made the index invisible. Now if I'm going to read the same condition, okay, it will read 1,000 records because index is there, but we made it invisible. It's not visible to the system anymore. But in the background, if I do any operations, the index pages are will update. It is like active only, but queries cannot use the index because I made it invisible. Why I made it invisible? Because many indexes I have it, I don't know which indexes to be dropped. So one by one, I will make it invisible and see the execution plans and where the execution plan is gaining the performance, where it is dropping the performance. Based on that, I can take a decision which indexes can be dropped. We are not dropping it, but we are testing the performance first. Then we are getting to know which indexes are good, which indexes are not good. Then we are dropping it. So I can make it the index invisible and visible. Come on, the space is gone. Just a minute. I'll explain this concept. This is important. I'm going to cover all these concepts in the performance tuning once. Okay. Again, it started filtering 194. So without dropping the indexes, we can evaluate the performance. That's a one good feature you have in MySQL. In other products, it's not that way. In SQL Server, it's a licensed product, right? If you want to disable the index, you disable it. it never get updated afterwards. If you want to enable, you have to rebuild the index entirely. Rebuilding means recreating almost. Okay, that is heavy to the system. Here in MySQL, you can just do the invisible indexes still update. Whatever the inserts, update, deletes you do, the index pages will update. It will be intact with all the statistics. When you enable, it immediately start using the index. You don't have to do anything. So that's one good feature what we have in MySQL about the invisible index. It's a outstanding feature out of compared to other products. Okay. So if you have questions, you can start asking, guys. Don't have to keep quiet. Right, high performance. High performance basically, your MySQL is doing good or not. Okay, example, I my workload is, one day is good, one day is bad. How do I know when there is a bad workload is going on? How do I really trace? We have three levels of tracing the queries in MySQL. By default, ongoing. Okay, by default ongoing, where you can find it. But if the query already passed, it is done the job, how do you really trace it? We have a general log. Every query, you if you enable the general log, every query, every connection, disconnection will get recorded for debugging purpose. You don't need any third party tools. If you don't have, still you can efficiently troubleshoot the MySQL performance using the general log. It is only for recommended. It's going to add more contention to the system, but still you need a debugging. Then you can enable the general logging, where it records every query that comes to the system. Okay, then we have a slow query. One more concept called slow query. If you enable the slow query, if a query runs 2 minutes, then it logs the details of that query automatically in the slow query log automatically. So you have all the queries, you have a slow queries, you have ongoing queries. Every level is covered. In fact, in MySQL, we have three different levels of logging for the queries: online, partial with a particular timestamp, and everything. You can capture it and then do the analysis on the queries section side. So it is a good performance product. If it is not performing, you can trace it also well without any third party tools, internal tools itself. How that can be used, how we can trace the queries, I'm going to talk very in detail in the module itself. I'm just giving you the information here. So buffer pool caching, adaptive hash index, it will create the index automatically within the memory for the memory based tables. If you are doing grouping, sorting, or whatever you're doing, it's going to create hash indexes automatically to improvise the performance. If you are calling too much of data, too many times, hash indexing also help to fetch the data so quickly, because it maintains that address of the data. In fact, multi-threaded IO, how many IOs you wanted to operate on the IO side, you can configure it. I wanted to run the threads, 10 threads for my operation in the background. You can mention IO threads in the config. So based on the configuration, your disk performance, you have to configure this. You can control, guys. You have lot of parameters which can control the performance, and that parameters makes your MySQL absolutely work well. Those parameters I'll explain. For now, you can control what is the consumption can be done by the queries. So you can control the performance, and you can trace the queries bad, whatever the bad queries are running. All that we'll see in the module. Replication high availability. This is so good. In fact, you have the object level, database level, server level. You can give a filter when you do the replication. Object, I wanted only few tables replication. I wanted only one database replication. I wanted entire server replication. I wanted multi-master replication, chain replication. Okay, and I wanted autofill or replication. So everything I want to cover. All this is where we're going to spend very, a lot of classes will be spent on this one, especially because there are many scenarios I'm going to cover where I work extensively. In fact, here, okay, we're going to talk about a lot. Pluggable storage engines is very another outstanding feature that we have in MySQL. Let me show this. Show engines. Okay, I'll explain every engine what we have. Every engine works separately. For how your data you are managed in the background depends on your storage engine. In fact, these are all storage engines. InnoDB is the one which is a popular and which is a default by default in the Postgres, sorry, in the MySQL. So this only supports the ACID compliant. If you want to do the ACID transactions or anything, InnoDB is the only one. So out of other are a federator, linked servers. Federator means linked tables, in fact. Federated storage engine, memory in memory, only in memory table. InnoDB is default asset compliant storage engine. Okay, my ISM basically is one of the storage engine. It's a legacy storage engine. Um, Developed initially. Okay, uh, let me create some tables and show you how we can claim for every table. It's a table level feature, not database level, not server level. Every table can follow its own engine in the background based on your requirement. So example, create table. Come on, just for use case, I'll explain every storage engine in detail. For now, just I'm showing you student underscore 100. Okay. So here I can mention the engine, what engine I wanted. Engine. By default, InnoDB. If I wanted to give InnoDB, I can give it explicitly as well. InnoDB. I can mention it will create, in fact. Uh, what it said, create table name. Varchar. Okay, I did not mention here data type varchar 100. So now I'll create one more table, 200 table with another engine. Which engine works what it does in the background, I'll explain in the separate after architecture. My eyes, right? This one. Same. Now, if I go and create another, okay. CSV is a one good thing. CSV format is a Excel format almost. How data maintained in the background in the Excel format. This require every field to be not null. So what it said, storage engine for the table doesn't support nullable column. So basically, when you want to use CSV format, every table should not be not null. Why it is so, I'll explain in the after architectures. Lot of things, guys. I'm just giving informational discussion today. I'm not finishing anything. So my sessions mostly you will find all are practical oriented. I don't focus on the theory at all. So now show create table. What engines you have for every table. So this is a table. So I'm going to use this, and let me, if I run this, it's going to tell you what is the storage engine you have in InnoDB here. Now, if I wanted to know for the 200, I have the storage engine here, MySQL. You can see that. And here 300, you have a CSV engine, storage engine. Because we supplied that, we have given that. When we created a table, we gave the storage engine, what storage engine we wanted. When do we want each storage engine? I'll explain after the architectural. I'm just telling you that we have many storage engines, pluggable storage engine for every table. It's not a server level, database level. Every table can claim its own storage engine based on the purpose of the table. Which purpose, what storage engine, what it does, based on that you understand. That I'll explain in the module only, not now. JSON document I just talked about, right? The Postgres supports the JSON data load, and JSON, we read the data also. We've seen here data model, JSON data model. Statement level rollback also I just talked about. MySQL does not follow the ACID, like all should commit or all should fail is not the case for the MySQL. Within the transaction, how many statements you have, some of the statements are failed, still whatever committed is committed, failed is failed, still you are under ACID compliant. How you are still under ACID compliant, only you understand after the architecture. So because the architecture plays very important understanding about many things, there I'll explain this statement level rollback. Okay, very in detail. Partitioning, again, partitioning, we have range based, list, hash, every partitioning I'm going to explain very in detail. Okay. Cross platform portabilities, like as I said, you can run this product in any of the platform, whatever the operating system you have, it doesn't matter, it runs on it. That's a one good thing, right? It's not tightly coupled, it works everywhere, in fact. Okay, comparison with other database systems. If you talk about Postgres, Postgres is a community. By default, you don't have any enterprise person, EDB is there anyway. That's a third party. Not Postgres is completely community driven product. There is no general body who manages entire support model for you. Okay, nobody is there. In fact, for Postgres, you have to go to third party people and get the support. For the MySQL, you have the direct product owner Oracle. They will give you the support. You don't have to go to anyone. That's a one good advantage compared to Postgres to MySQL. Support side, you have a direct vendor who are giving the product, who are supporting the product. Postgres is not like that. It's given by community, supported by some third party EDB, enterprise DB. They're third party. They are not direct community people. They are third party. They are licensing the product. They are giving the full support on the product, but they are not direct vendors who are giving the product. In fact, so that is there. So MySQL offers simpler setup and tuning. In fact, wider hosting support, better raw read performance for web workloads, and a larger pool of junior developers. See, I will compare this with the support only. Rest of the things anyway. If you talk about Postgres is good or MySQL is good for the large data, Postgres only good. Postgres has better features than the MySQL to support a large data comparatively. Postgres is much scalable than the MySQL in terms of resources, in terms of data processing power will be high. Complex queries can be written. MySQL is not like that. It's not in terms of data scaling. It's not so good like Postgres architecture wise. It is slower comparatively, but still, why it is getting implemented? Web applications, lightweight web applications, all are using MySQL only in the market. At least 65% of the market and the MySQL only, which are web hosted application, lightweight applications. So all lightweight web applications are running on the MySQL, not on the Postgres. Postgres is not for the lightweight; it is for the robust, complex applications can use. But all lightweight and they don't do much of the data workload, then they can come to the MySQL. In fact, Oracle, why can't go to Oracle compared to MySQL? Oracle is so costly, you can't use it. It is not something you can buy it at cheaper cost. Community is free. Community is free completely without paying anything. You can use it. Oracle absolutely costly. You can't use it. That's one comparison wise. Microsoft SQL Server is licensed again. It's not free. At the same time, it is something mostly used in Windows platform. Okay, Microsoft SQL started giving on the Linux platform SQL Server 2017, but still market nowhere implemented. Very rare, 1% probability you see that the Microsoft SQL runs on the Linux platform. Only 1%. So mostly you can say that tightly coupled. It is integrated with the Windows. In fact, MongoDB, it only supports NoSQL data, not SQL data. Relational data is not supported. So if you want to know SQL and SQL together, MySQL is only solution for you. In fact, MariaDB is again community driven. You don't get the immediate support. If something is broken, some buggy thing is there, you can't go and blame anyone. It is open source. Okay, if it is a buggy means buggy. That's it. You can't go. You can't really complain on anyone. It's an open source, free to use tool, database system where you don't have a direct immediate support. Nobody can guarantee you the support, but MySQL can support because it is handled by the Oracle. So compared to other products, these are the advantages. Here, Postgres basically support is one side. Okay, MariaDB is also support is a strong point compared to this. MySQL has a strong point towards the support. MongoDB is only NoSQL product, and Oracle has a licensing model, and it is very costly. You can't even compare. Microsoft is a little cheaper compared to Oracle, but still it is mostly used in the Windows platforms, not on the Linux. That's why you can't compare. MySQL has its own advantage, in fact. Why Oracle gives MySQL community for free? I said this in the beginning itself. So initially there was a European Union. The Swedish company is comes under European Union. They filed a case against the Oracle that they are going to take the MySQL free product can become licensed. People can't use it. There are a lot many people already implemented. So they've passed a law. So Oracle also agreed that even you are purchasing this product, it should be open source only. That's the rule. Oracle agreed in 2010. they said they will give this product for next to 15 years at free of cost. 2025, that contract is ended. Still, Oracle is giving the community MySQL Server as open source only because they understood the access to the market is very important. They're making it licensed. So they are giving the MySQL product still free because they are getting the money through the APGL. Like open source is getting implemented in the third party software. They're getting money from there. They're getting the money from support. They have enterprise MySQL Server also. When they're using MySQL, when the company grows, they'll go to the enterprise side, they get the money. Even the existing companies become bigger, they can go to the Oracle as well as a customer. So they are seeing this trend. Okay, that's where MySQL is given at free of cost to the market without any money. Okay, because Oracle are notorious in terms of costing very very high. In fact, if it is small company, you have to sell entire your company to pay the bill. Okay, that one core $47,000 per year. One core, understand how badly they are charging. So but still they are, in terms of licensing, they are very stringent, they are very, they'll very costly, but still they are giving MySQL community edition at free of cost because they understood the access to the market is very much important than giving it, getting the money. They're getting the money more than what they're expecting from the community. Because of the community, they have the more reachability, more adaptability of the product. Slowly they are getting towards MySQL enterprise, MySQL support, APGLs, and then slowly they are going to the enterprise, the Oracle side. So all are there. That's how they are actually driving this product at free of cost, though the contract to keep this product is ended in 2025 itself. Still they are continuing, they'll continue also. That's what their commitment as of now. Okay, limitations wise, unlimited, how many databases I can create in a single post MySQL server? N number of database, there is no limit. This is many number of databases. As long as your hardware can support, that many databases you can create in the MySQL. There is no limit on the number of databases. One single table can grow up to 64 TB. Single table I'm talking about. Single table can grow up to 64 TB is too big, in fact. Okay. One row size can become, like if you look at this one, 65 KB row size. In fact, blob text columns can be any big. This is not applies to the blob text column based. Normal text based operations can take up to, this is a maximum row size. In fact, uh, columns. How many columns you can have? 1017 columns. Okay, effective limit due to the row size constraint. So these many columns you can have single tables. Single table can have these many columns. One index can have 64 secondaries of, 64 indexes. One primary key can create a clustered index. 64 secondary indexes you can create. Total 65. So one primary key index and 64 secondary, total 65 indexes you can create per table. In fact, index key length. Key length means the name of the index. In fact, can be, you can see that 3 KB. 3 KB. Nobody create that big name. Basically, name itself can be 3 KB of size. The name of the index. Okay, maximum connections 1 lakh. You never see that big at all. You would see roughly 200, 2000, 3000, maximum 5000 max connections are configured on the server on the larger systems. Okay, you don't go to 1 lakh. 1 lakh is too big anyway. Okay, I never seen such. Maximum I've seen 5000 concurrent connections. What we see as maximum connections in the config. You'll see that. So this is all informational, guys. Nothing much I can say here. Your database is called schemas. There is no schema concept in SQL Server. Database schema, under schema you'll have a tables. Postgres, you have a database schema and tables here. In MySQL database table, that's it. There is no schema. Schema means database here. Okay, let me show this. Show databases. Show databases is same. Show schemas is also same. Ah, shows. Okay, your database schema is same. They are interchangeable words. Your schema means your database here. There is no schema concept in MySQL. Direct table, database table. That's it. There is no another layer called schema in the MySQL. Absolutely database and table. That's it. Schema means database itself, and table like to standalone like database and table. That's it. View, stored procs, triggers, events. Actually, something you can automate. You want to run automation within the MySQL. You want to run a job at one point. You want to create your own scheduler. Events will help you to do the automation. We'll talk about in the module anyway. Table space is another thing where you manage the storage efficiently, mapping the some databases into one table space, some of the database to another table space, or some of the objects, some tables. You have all levels of privilege here to map. Okay, I was talking right where here one database can go to one table space, one table within the database. A table can go to here, one table can go to here, so that if I'm hitting this database, my data come from here, here, here. One database distributed to three different volumes, in fact, based on the what object you created where. So you have that probability using the table space concept only, in fact. Used by most companies, web applications, especially where lightweight applications where use it, where MySQL highly used basically. Web application, web applications where MySQL highly implemented, in fact. Career demand, why? Because the more implementation, more opportunities will be created in the market, obviously, right? So it is creating, you know that, right? Every company has MySQL, at least little footprint mandatorily. So the more implementation, the more job opportunity. Simple. So the demand will be there, obviously. Free, right? It's open source. One good driving factor for the product to grow in the market is it's a free open source. Free open source free basically, and it is used by many bigger companies. Facebook, Twitter, YouTube. All companies are using for all the web application purposes. In fact, all companies are the customers of MySQL, in fact. So if they are that big companies are implementing, you have the opportunity to go to such big companies also, which means, so if it is getting implemented, you can go and grab the opportunity kind of. Okay, they are evolving feature set. They are adding more and more features to make it competitive because you have MariaDB. There is one more like a distributor is a Percona MySQL. You have Percona MySQL is another third party vendor who is giving the MySQL as a open source as a licensed also. MariaDB is completely open source. No need to pay any to anyone basically. But Percona, you have the paid version and free version. They also developed the MySQL. See, just like MariaDB. MySQL got forked into MariaDB just before the Oracle bought. Is one thing, one journey. Percona is another third party people who are building the MySQL equivalent to Oracle MySQL and MariaDB MySQL, and they have their own third party plugins. They developed their own plugins to make it even better the product. Okay, Percona MySQL is also there. So we have multiple distributions. So when you have such, you should be competent. If you are not competent, you lose the race. That's why they are developing the MySQL very rigorously to keep the outstanding of this product. The more outstanding product, the more implementation. The more implementation, the more job source you'll get it. So where do you get the support? In fact, this is one thing I need to explain. Bugs. If you go to here this site, what kind of bugs are there and how it is resolved? You can go to here this bug system example. I wanted to see latest 30 bugs. Okay, and then search. It will display all the bugs. These are all raised by community people. Okay, you go to any particular bug, they'll have a good discussion about that bug, how it was raised, and how the issue was resolved, everything. Okay, you can refer the bugs, existing bugs, as a solution for your issue if it fits. Okay, into your issue. This will be like a documentation. Whoever is connecting with them with the bug or with the enhancement, they are actually adding up here. Then they release as a minor version anyway. So you go and check here what is the issue. Someone is asking about some divisor is zero must return some issue in the output when it is a divisible by something. They are seeing something. So what is the solution for it? They are discussing about it. So there are many bugs where you can have access to see them. If I wanted to see example 90 bugs and then search, it will give you all 90 available bugs, in fact, and you can go and explore yourself. You can see that 8,336 bugs are discussed here, okay, since created. So there are a lot of data where you can see the versions also mentioned, right, clearly. So which version this bug kind of. So you can see that, this will help you to understand the bugs that you have, how we can correlate your issue with that bug if at all you find relevant bug kind of. Okay, security vulnerabilities. If you find any security vulnerabilities, you send a mail to these guys. They will respond. They will respond. There is a support for it. You see some security vulnerability the product is going through, and you want a solution for it, you send a mail to these guys. Oracle will support. Okay, and then mailing list. If you have any support, if you want to know any example, I have a new implementation. I don't know how to implement. I got the product as a requirement, and I wanted to build some solution to it, and you don't know anything, you can send a mail to these guys and have a discussion. They will respond, guys. Whatever the emails are given, they are official emails. In fact, they'll help you to get some response, and to have some discussion conversations about your requirement, and they will guide you how it can be implemented and all that. So Stack Overflow, Data Stack Exchange, these two are the biggest bloggers where you get the support, where you can post your outstanding issues, and then make other people aware. It is the largest blog for the MySQL. These two, Stack Overflow and DBA Stack Exchange, they will give you lot of information. So you can see that how many answered, 5 lakh questions are answered on these sites. In fact, go and get your questions answered, or you have a solution for something and you can give the solution. You got an issue, you resolved it, you go and post it there, it will help the community. So all that contributions are there in these sites. Documentation, if you go to this one, there is a lot of documentation added on the website. So, see, guys, I'm not finishing anything here. Okay, just only informational whatever I have discussed so far. Okay, reference manual. If you go to here, you have the version here. Which version documentation you're looking for? In fact, right? You select that one. The documentation will get open. What is there? All the documentation is given here. Okay, documentation about what you are looking at, installing Postgres. You click on this. It is like what is what. They don't talk about troubleshooting, but they do give the information. Every product has such documentation. Any product you pick up, they have their own documentation. Documentation does not drive you end to end. They will only cover you the generic statement and understanding. In fact, so documentation can be, if you have a real good interest, go and look at these sites. They'll help you to understand some of the information, right? Good thing to know. So this is about the demo, guys. Like, I did not cover anything technically. Don't think about anything. I have opened my SQL shell. I was talking here and there. This is all there, very detailed discussion in the respective modules. Even you don't understand, just don't have an idea what I was trying to talk. In fact, it is getting recorded anyway. I'll share all that, right? So module wise, we have lot many modules. 22 modules I divided this course into. I will add two more. In fact, I have in mind. So MySQL architecture, installation, file system. This file system is important. We're going to go through every file system that you have in MySQL, and storage engines architecture again, like memory-based InnoDB especially. InnoDB is the largest one which is implemented in MySQL. So you should know how it works internally to manage the data. DB locking, management and security, backup restores, physical backup using third party backup systems also I'll cover. Percona third party backup I'll cover because it's very much important. We use a lot. Point in time recoveries, replication is a very big module, guys. Especially replication, where we're going to cover lot many scenarios, at least 7 8 classes, I guess we're going to spend, because it has many things. In fact, inside that replication issues, you can skip the errors, you can ignore the errors. There are many things we have to cover in the replication. So replication is a very biggest module for us, especially. Okay, and performance tuning, OS level tuning, high availability. This is high availability, automatic failovers, and replica set, cluster. We have many things I'm going to cover very in detail. partitioning, and major minor upgrades, monitoring. So 22 modules here, and I'm going to add one more module, a database table space management separately, to make the that area is robust. In fact, we need it. So total 23 modules we're going to discuss for this course. In fact, content wise, don't worry. I'll keep it more of practical than the theory part. I don't cover much theory in any class. Only the practical, because you theory you can get anywhere. Practical side is important. My sessions are more practical and troubleshooting oriented, not theory oriented, because you should do your job in the real time without issues. Understand every bit of it so that you can take a proper call to make the system better. You understand by the end of the course anyway. It's my guarantee that I'll give a best content. It's your thing. You have to practice and follow. That's your job. So anyone want to talk before I stop the video? Any questions from anyone? Fine. I'm stopping it here.